Hey kids, one last lesson, very straightforward, for real, very straightforward equation and concept. One very nice extension, which we'll look at too. Okay, if you know the REQ formulas for parallel series, you can solve that two ways. Check your answer. R plus R equals 8, 1 over R plus 1 over R equals 1 over 2, so R equals 4 ohms. Alright, watch the video.
In this video, we're going to connect two different light bulbs in parallel and then in series, and use our observations to help us understand the difference between those two light bulbs. So here I have two different light bulbs. You see that this one is much brighter than that one right there. This is a series connection. We have a pack of 3 batteries, and we have one loop, we'll call it the green loop, with the first light bulb, and then the second loop, the white loop, with the other light bulb. So these two light bulbs are now connected in parallel. This one is brighter than that light bulb right there. The voltage right here is 4.5 volts, and there's a particular amount of current coming through this black wire, and then it hits a junction. Now think about what happens. What happens to the current when it hits this junction? How much current goes into the green wire, and how much current goes into the white wire, and subsequently into the two light bulbs. Now what I'm going to do is I'm going to disconnect the circuit, and I'm going to build a series circuit using the same light bulbs. So let's connect these two light bulbs in series, and we'll connect that light bulb right there. Now get ready for this. Make an observation. Aha. Only that light bulb appears to be lit. This light bulb, I don't see even a glow coming out of the filament. But this one is very, very bright.
Okay, so light bulbs light up. This should answer a question that I could have asked a long time ago. Voltage? No. When current goes through a resistor, it goes from high voltage to low voltage. It goes from high energy to low energy. That energy is given off. It's transformed. It's released. What happens to it? Oh, I know. Well, of course you know now. It becomes light. Or for resistors, it becomes heat. For light bulbs, it actually becomes both. That release of heat and light is a change in energy. We can describe the power as the change in energy or work per time. Now, you can connect a light bulb to a high voltage or a low voltage. You can connect a light bulb to a high current or a low current. How does voltage affect the brightness? How does current affect the brightness? Tell me now. It's not a trick question. High voltage, bright light bulb. High current, also bright light bulb. P equals V times I. This makes sense if you remember the definitions. Voltage is energy per charge. Current is charge per time. So if you plug in and cancel, you get exactly work over time, which is power. That makes sense. Think of the analogy of the water flowing down the mountain. The voltage is the energy per kilogram of water. If you have a really tall mountain, every kilogram of water that comes from that really tall mountain will have a lot of energy. So the higher the mountain, the higher the voltage, the more energy you get to grind grain. But also, the more water, the more flow, the more current will also give you more energy. So a high voltage is a lot of energy per charge. A high current is a lot of charge per time. Both affect the power. The power is in watts. And for most light bulbs, the power is given in watts. 25 watt, 100 watt, 200 watt, whatever. But that's only how they're supposed to be used, which sounds kind of stupid, but that's what happens when you plug them into your normal wall outlets like these over here, which are 120 volts. So, let's say I have two light bulbs, a 120 watts and a 60 watts. The 120 watt will be brighter, which is what you expect because it has a bigger number. But what kind of circuit did you make? So let's say I have a 60 watt and a 120 watt. This will be much brighter than the 60 watt. In fact, it'll be about twice as bright, in theory. What kind of circuit did you make if you take two lamps and connect them to two power sockets and find this one's brighter? What kind of circuit is that? Alright, let me stop. This is true. Since this is true, this is true. And so is this. Alright, if you want to write this down and stop there, that's the important takeaway from the lesson. If you want to answer the video, check this out. If you connect both these to separate wall sockets, that's a parallel circuit. So basically, you made this. When this is 60 watts, this is 120 watts. This makes sense. Whenever you connect things to your wall sockets in your house, you're making parallel circuits. If you have like a blender and like a refrigerator and like a lamp, you would never connect them in series. One, if you did and you turned one off, they'd all turn off, which is obviously bad. And two, they're designed for this voltage. If you put them in series, remember, if I make a circuit like this, sorry, excuse the mess, art is hard. These three resistors split up the voltage. The 120 might be 40, 40, 40, or 30, 40, 50, or 10, 10, 100. It's going to be split up, and they'll all be not as effective. So for things to work properly, they're going to be connected in parallel so they each get the full 120 volts. So that's how things are supposed to be. But you don't have to connect things the way they're supposed to be connected. If you have a box and the box says 60 watt light bulb, the light bulb's not always 60 watts. You can connect it to like a little tiny like watch battery and it'll be really dim. You can connect to like a car battery and it might be brighter. You could hook it up to like a lightning rod and wait for like a lightning bolt to strike it and it'd be super bright until it explodes. The power is based on the voltage and the current. But you can connect a light bulb to any voltage or give it any current, and then the power will change. What about a light bulb is constant? What about a light bulb is an intrinsic property based on how the light bulb is built that never changes? That wasn't much of a question. There's only one thing that's left. If you can change the voltage, that'll change the current. Resistance is constant. So a 60 watt bulb and 120 watt bulb, those are the normal powers. But let's find the resistances that are always the resistance. 60 watt first. 60 watt bulb. Power is I times V. 60 watts equals I times 120 volts. 0.5 amps equals I. That's not what I wanted. We wanted the resistance. R equals V over I equals 120 over 0.5, 240 ohms. So a 60 watt bulb actually has a resistance of 240 ohms. 120 watts. Alright, the number 120 was going to show up like 5 times. I apologize. Look at the units. P equals I V. 120 watts equals I times 120 volts. This is the power that describes what the light bulb is made of, how light bulb's made. This is the voltage of a standard US household supply. I equals 1 amp. R equals V over I equals 120 volts over 1 amp, 120 ohms. So a 120 watt bulb connected to a 120 volt power source has a resistance of 120 ohms. In fact, it always has resistance of 120 ohms. So we got this is for a 60, this is for 120. Now, what did the guy in the video do? He used the same voltage, but instead of parallel, he made a series circuit. Alright. Remember, this is the 120 watt bulb. This is the 60 watt bulb. In parallel, this one's brighter. Take a guess. Which one's brighter now and why? Okay, let's find out. This is a series circuit. So Req is 120 plus 240, 360 ohms. I is going to be V over R, 120 volts over 360, 1/3 of an amp. Usually you should not leave it in fraction terms, but it doesn't matter because I said so. Okay, so P is I times V. Let me make a little more space. P equals I V, 1/3. Oh, here's the trick. The V's are not the same. The V's get split. Let me write this out nicely. So this is the 120 watt bulb. This is the 60 watt bulb. Okay. I could use these shortcuts, but I'm going to do the whole thing so that I don't confuse myself. Even though I never confuse myself, and I never ever re-record videos, but because I messed up so much, and I'm just amazing. Alright, for this bulb, this is R, this is V, this is not V, this is I. So for this bulb, V equals IR, 1/3 of an amp times 120 ohms is 40 volts. Not 120. Remember, in a series circuit, it gets split up. Now this one, 1/3 of an amp times 240 ohms, V equals 80 volts. this makes sense. There's more resistance here. So the current comes out of the battery with a certain amount of energy. It loses less energy where there's less resistance. It loses more energy where there's more resistance. So the voltage drop is 80 here and 40 here. That makes sense. And the sum is 120. That also makes sense because the total voltage for the loop, gained and lost, must be 0. So now we can find the power. For the 120 watt bulb, the power is I times V. It's 1/3 times 40. It's like 13.3 watts. For the 60 watt bulb, it's I times V. It's 1/3 times 80. It's 26.7 volts. 0.7 watts. And that's exactly what we saw in the video. The 60 watt bulb is now 26.7 watts. The 120 watt bulb is now 13.3 watts. This is much brighter. In the video, the difference was much more, so this was so bright you couldn't even see the different bulb. But as we found in this case, the bulb that normally has a lower power because it has a high resistance. When they're in series, look at this formula. In a series, they have the same current, so the higher resistance gives the higher power, and that's what we found. Alright, great job on this unit. Now we can just relax and wait for the AP and get all 5s because we're amazing. Bye.